Thanks everyone for coming. Good evening. Thanks you for coming on this freezing Wednesday night. I feel very honored to be here. I am not a Java specialist myself, but I'm happy to be here to share some of my thoughts and my work around JVM kernels we built in Jupyter world. So I hope in this talk we will find how it could be fit into engineering or Java developer scenario. As it is, I think it could be a research and a prototyping platform if you want to get some machine learning preparation for Frank's presentation next time. Yeah. So I would like to introduce you to the Beaker extension for Jupyter, BeakerX. So before that, let me first introduce myself a little bit. My name is Tiezheng Li. So Tiezheng. So I came from China. I came to the United States 3 years ago. I studied Columbia University, majoring in computer science, and then I went to Two Sigma and become a software engineer here. So in Two Sigma, we are a systematic investment manager, and we are founded at the goal to apply the cutting-edge technology into the data-rich world of finance. And here, modelers and engineers, we are working together to find value among world's data. And engineers are building reusable infrastructure for modelers to better find values in data. And so I'm working in a team called Modeling Tools. And here we are building tools for modelers so that they could easily discover, compute, analyze, visualize, and publish data. So BeakerX is just one of approaches to accomplish that goal. And in today's talk, I would like to introduce you to BeakerX. So I'll talk a little bit about the history. So BeakerX has a predecessor called Beaker Notebook. So I'll speak a little bit about our motivation and the path we take from the original Beaker Notebook to BeakerX today. And then I'll give a live demo about BeakerX features along with features in JupyterLab. So before I speak, let me do a little bit survey. So who in this room has used Jupyter Notebook? Okay, good, thanks. And JupyterLab? Cool, thank you. So I think, yeah, so Jupyter indeed is very popular tools in data science and the research area. I will go a little bit, I won't go that deep, but I'll give a short introduction about Jupyter Notebook and JupyterLab features in my talk, if you're not so that familiar. Yeah. So I would like to talk about the motivation, so why we want to build BeakerX and what it is about. So it starts with our vision for data science. In data science, we think that data as the foundation for data science, and they should be easier to be discovered. So we want to have discoverable data. And once we have the data, we want to apply the data analysis and modeling portion of the process. And that process was enshrined in the notebook. And then we call that one Jupyter Notebook. And it's also the tool that we're building inside Beaker Notebook. And when computing the data, you may want to face the problem where to compute a large, kind of like scalable data, and you want to have distributed computing. And once you have some findings, another critical point is that you should be able to do publication, and you should be able to share it with others, and you have more collaboration with your peers. So that's why we want to build a Beaker Notebook. We want to set down these 4 things for our users. And so we have the original idea for Beaker Notebook in 2013. So at that time, we were inspired by Mathematica, inspired by IPython, inspired by the REPL concept, which is read, evaluate, print, loop. So we think that notebook could be a very good metaphor in user interface for researching and prototyping things. So at that time, we built Beaker Notebook, and you can think it as Jupyter Notebook because in architectural, looks very much like Jupyter Notebook, and it's a web application where you will have a notebook. So it's a front end, looks like a notebook. You have code cells, and in each code cells, you could write a bunch of programs, and they could be run interactively and give you the results. And each front end is connected to a specific kernel, so that actually you can write code and do some experiments in your web browser. So that's Beaker Notebook. And I think what we differ from Jupyter and what's unique from others is language. So when we're building Beaker Notebook, we think that language really matters. I mean, in human world, I found language really, different language could have different advantages in different scenarios. I mean, for example, I find English very easy to convey ideas. And when speaking English, I found myself in a fairly positive character. But when speaking Chinese, my native language, I would raise the example for Chinese poems, where the characters are limited, so they try to put the unlimited beauty into some limited words. I think that's the same with computer languages. So each language is designed for a reason, for a specific need, and as developers, we're using Java every day. But when we want to deal with some data, read those data, we may want to try Python for its great library support, like NumPy and Pandas. And certainly we want to write documentations every day. Write documentations, we don't want all of them to be inline. We may want to use LaTeX and Markdown for their elegance. So when we are going to build a notebook for our users, we think we shouldn't have lock our users into a specific language. We should allow them to write in any language they need. I mean, in Tiezheng, we support a wide mix of different languages, whether like Python, like Groovy, sometimes Clojure, Java, things like that. So the notebook we built should allow our users to write in those different languages and should be able to collaborate with each other. So I think the most important feature we built in Beaker notebook is about language. So here we left language as a variable for user to choose. So I'll explain what does it mean. So you'll see this is a list of all the languages that we support. You'll see very famous choices for data science like Python and R, and also all the JVM languages like Java, Clojure, Scala, things. Also, there are other choices like Julia or languages to visualize like JavaScript and HTML. So in a Beaker notebook, I would say it's composed of different code cells. In every code cells, you could write in a different language. For example, in the example here, let's say you are going to export some data. Then you could first, in the first cell, you use Python, the pandas library, to read some data, because they provide great utilities for reading and parsing those data. And after that, you could, let's say you have an expertise in R, and they are more easily in analyzing and visualizing data, so you do some research in R. And then you find another fancy visualization library, like D3 in JavaScript, then you can pass those data to JavaScript to visualize it. So here, we built an internal, like it's a universal object inside Beaker notebook. So it is storing the data and passing data between each languages. So in this way, you will be able to write in different languages. We think that this is very natural because it's a notebook. In a notebook, you should be able to you have the freedom to write in any language that you know, right? And also we think that's essential because when you are researching something, sometimes you may not know what is the right tool, you may not know what is the right direction, you may want to just do research and prototyping. And in this way, because you could use the most appropriate tool in each stage in your research. So, and also this allows people to collaborate better. I mean, in this case, for example, a Python developer and R developer, they could collaborate in a granular level of cell by cell. So they don't want to have wrapper functions, write them to cells, write different parsers that would save some time. So this experience will be like a symphony rather than a solo. So that's the polyglot feature we provided in Beaker Notebook. And besides that, in Beaker Notebook we have some additional features. Like as you can see, there are some plots, like a heat map here and a histogram. Also, there are table. It's an interactive table with heat map. So these are the expertise we have in data science, and we think that those visualization libraries, according to our need and our understanding for data. Also, we provided with a publication server where if you finish a notebook, you could upload this notebook to the server, and then you will get a shareable URL so that you can share this URL with your colleague, with your peers for further collaboration. And that's I think the main features we have in Beaker Notebook. So this is a short lifeline for Beaker. I think this project has been successful in Two Sigma. Researchers have been using them, and we also think that's valuable because that's the first open source project at Two Sigma. So I think it's a great step from a place where sometimes it's called the secret world of finance, and then we decided to work on open source project. So in May 2014, we have the first open source beta, and in the following year, you can see we add a bunch of different kernels, and in April 2017, we have the external BeakerLab Alpha. So that's kind of like a hosted service. It's the publication server I talk about. So you can visit BeakerX Lab and add your notebook here and share work there with others. But we decided to make a pivot in the late 2017, in 2016, and we decided to move to BeakerX. So I'll explain what happened then. We decided to make this pivot because we really have learned something during the development in the open source world. So I just said we built a web application with the front end. So it provides you with a shared environment of interactive computing, and it's built against Jupyter. So at that time, Jupyter is also emerging, and we do have learned so much from this process. So Jupyter Notebook is a notebook, but for now, it's not a notebook itself. It's becoming an ecosystem of a bunch of different tools. As you can see, there are many tools building around Jupyter. For example, the JupyterLab is a new front end, which will provide you a bunch of computing experience, and we will see it later. And there's MB-Convert, which could help you convert your notebook into other formats, like an HTML or like a specific Python module. And there's Jupyter Hub, which could help you expose your Jupyter server for other users to visit and make a hosted service. There are also things called Binder, which could run the Jupyter service from a GitHub repo, which provide you a lot of which is very easier to access. Also, there are NB Viewer, viewing the rendered HTML version of the notebook. Also, the thing they call NB Present, so you can also write a slide in Jupyter Notebook and present to others, so that in the presentation you'll be able to have a code cell, and when you're showing the code cell to the audience, you can actually run them and let the audience see what's the result there. Also, one of the most interesting I see at the JupyterCon last year is called NB Grader. So, as I told, the professor would use NB Present to present his slides to students, and students would hand in their homework also in the Jupyter Notebook, and use this with the help of the NB Grader. It could be graded, automatically graded, and then send students the results. So it's really there are so many tools building around Jupyter, and people are using them, people are loving them, so the trend is just irresistible. And building a software could be relatively easy, but building such a community is very difficult. And when such a large community has formed, it's very difficult for any single entity to keep up with. So we decided to make a pivot, and then we want to develop the next generation for Beaker Notebook called BeakerX. So here we don't want to reinvent those views, right? The views here, I mean the web application, the basic architecture like the UI. So these are already provided by Jupyter. I think the correct thing to do is to bring the expertise, the unique part that we have in Beaker Notebook, and bring them into Jupyter world. So we decided not to fork Jupyter. We decided to utilize the great ability to extend for Jupyter and make BeakerX an extension on top of Jupyter, so that we could be able to keep pace with the development for Jupyter world. And it's a hard decision, but we think that's the right thing to do. So at the end of 2017, we made this decision, and there are really questions ahead of us. whether if this is easy or if this is possible. So at that time we made some experiment with some proof of concept to see whether we could do this migration smoothly. But surprisingly, the result is very good. So this gives us much confidence of moving Beaker into BeakerX as a Jupyter extension. So we did it after 9 months of work at the JupyterCon last year. So we released the first version of BeakerX, and in this year in July we have BeakerX 1.0, and it's still under very active development now on GitHub, and the current version is 1.3.0 now. We're still adding new features, and we're glad that we did it. During this process, I won't go into too much technical details in how we do that, but I do have some figures for you to share, some interesting figures for you. So this 94% means that in the current BeakerX, 94% of the code is reused in classic Beaker notebook. Yeah, so now that my job is to write a small portion of the code of the remaining 6%. Yeah, I'm having a year-end review now. I don't think that's a number to mention in my performance review, but apparently this gave us the confidence how easily to extend the Jupyter notebook and how we could do that and why we could do this very fast. And on GitHub we have received a bunch of stars. Also we have some active users. We have formed our project and made their own modification and announced. So here, what we bring on the table is a unique addition to the Jupyter ecosystem. So we bring to the Jupyter world a bunch of JVM kernels, including Java, Groovy, Clojure, Kotlin, etc. And so that you could write those languages in Jupyter Notebook. Also, we bring the true polyglot analysis, as we mentioned before in the previous slides about the polyglot experience. Also, we bring here the interactive tables for users to explore and have findings in their data. Also, we have time series visualizations that we use inside Two Sigma. Also, we made some more integration, so we utilize the Jupyter widgets to create more UI inside Jupyter. One example is this Spark integration, where Spark users could use a UI inside Jupyter to monitor their Spark jobs. Yeah, and also we also made this collaborative publication so the user could easily share the work with others. And I'd like to make the latter part of the presentation a demo of what BeakerX is and also demo of some JupyterLab features. So this is what JupyterLab looks like. So if you're not so familiar with that, that's a little bit different. So JupyterLab is actually a different UI on Jupyter Notebook. The underlying model and protocol doesn't change, but the UI totally changed. So I can also redirect you to the classic Jupyter. So it looks like this, where you have a list of files and browsers. So we call it tree view, and you can navigate here. Let's say navigate to documentation, just like a file browser, and then open up notebook. And then this is what the notebook looks like. The notebook starts with a kernel. So I'm using the BeakerX Groovy kernel right now. So this front end is connecting to a kernel and backend. The kernel is a Groovy process. So now user could write code here in those code cells, and those code cells will be sent to the backend kernel to execute and then send back the results. And I think the experience, the advantage of having such experience is to have documentations along with your codes, so that it's much better. If you want to do things step by step, it's much better for you to do prototyping or researching. Yeah, so that's a classic book. But in JupyterLab, you can see we don't have the tree view anymore. The tree views are integrated as a sidebar. So in this sidebar, you could also do navigation with a notebook right on your left, on your right. As you can see, I can navigate here. Yeah, and also open the same thing that we have. Open up that. So you can see these notebooks are in the same tab and in the same window. So I think this is better because once you have turned off your Jupyter notebook, let's say turn off your browser, you may lose all your open up notebooks. Let's say you have, let's say 10 or more notebooks open. When you close the browser, they're all gone. Certainly, the Chrome browser will remember it, but you have to find them. But in this case, so if I shut this window down and reopen that, as you can tell in the URL, it's still pointing to lab only, but the workspace, the notebooks that you open are remembered and they're reopened. Yeah. And we are having this one table. The other advantage that this could actually be dragged to the separate table, like what we did in normal IDE. You could drag as you wish, like this. So if you have multiple, you have a very large screen, multiple screen at your home, this could be better, like the movie experience. Yeah. So JupyterLab introduced a concept called workspace. So actually this, the layout, the notebooks you open, all the sessions that you open could be saved as a workspace. For example, I'm using the default workspace. If I go to duplicate that, so I'm seeing that the warning tells me to please use a different workspace, which means that I could create a new one, like JavaSIG, to switch to that workspace. And you can see the URL changes to workspace JavaSIG, and I can open up anything that I want here and arrange them randomly. Next time I go to open up Jupyter, as long as I pass in the JavaSIG here, so actually takes me to the workspace that I know with here. So it's like the experience with Tmux. That's the better thing brought by JupyterLab. And JupyterLab also supports a bunch of different documentation type. For example, you can open up a markdown here. So this is a markdown. So close them. Right. So in our work, we have to write documentations fairly frequently. So what I like about JupyterLab is that it provides you with an option to show markdown preview here. If I open it up, it gives me this. So what you see is what you saw, this page. So you can have them in parallel and can even work on that. Let's say if I say contributing to BeakerX, and actually that's getting automatically updated here. So there's like tools for, there are tools like Overlive who do that, and because I have JupyterLab, I never use that. So this is because in the implementation, the models and views are actually separated. So all the documentation we opened are connected to the same model, but they could have different views inside in our browser. So they do have a seamless update to each other. And the other thing I like in this Markdown widget is that in Markdown, so we are documenting our software. So sometimes we will write some like code samples. For example, I want to say input method, like print hello. Yeah. For example, this is my code sample, and I'm writing this Markdown. So I want to check if my code sample is correct. So I could say create console for actor, which asks me to select a kernel for me to run. So I'll say, and what I do is I press Shift Enter here, which will send my code directly into that console, and it's getting executed automatically. So this could help you, to verify if your document works. And this is a live kernel. Certainly, it could store variables and store states. You can easily play around with that when you are writing a documentation for your software. Yeah. So that's interesting. Also, besides Markdown, you could also open up things like various type, like a PDF, cheat sheet for BeakerX PDF inside here. So Also, we could do CSV image files like Butterfly, Zoom, and Zoom. Also various types like CSV. So CSV inside this notebook, and the drag wheel. This is something that the classic Jupyter doesn't have. And one thing I want to mention here, that you can see that the scrolling experience is fairly smooth, because the default implementation is using a library called Phosphor.js, which is very efficient. Sometimes it could allow trillions of rows at the same time to browse in your browser. I don't have that large CSV right here, but I can show you an example on their website. So this is a demo by Phosphor.js. As you can see on your top left corner, so this is actually trillion rows. And trillion rows could not be opened up by Excel or other tools or the text editors, but here it could scroll very smooth. Yeah, and that's the good things brought by Jupyter, the powerful thing by JupyterLab. Yeah.
So I have a question.
Mm-hmm.
So just I'm still trying to get my head around BeakerX. So Jupyter is a server, right?
Yes.
BeakerX is a bridge to connect a different language, like a JVM.
Yes.
So what type of bridge is that? Could you give me any details on that bridge?
Sure.
You're feeding, like in a Java case, I
Yes.
write some Java code. Are you feeding it to a JVM through like JShell, or are you feeding it? You go through a whole compilation process.
You go to the compilation process. I mean, I can take, for example, so I'm just showing up the features for JupyterLab. I haven't gone into BeakerX features, but I can introduce that right now. For example, you have a Groovy or a Groovy kernel. So you have some code in this kernel. Let me just open up some documentation here. Let's say this table, for example. So I have this code. So that piece of code is being sent to a parser. Being sent to an interpreter, right at the back end, and we will fetch the output of that and put that and transfer and serialize those outputs in the sense of the front end, the browser. So actually, this piece of code is getting sent into the Groovy kernel, and the Groovy kernel is returning the output. And so this table widget you see is the widget that we built in JavaScript. So we render the output in those widgets. That's actually how BeakerX works, and that's actually in truth for all languages.
So I'm assuming that the BeakerX is a C language hook.
Mm-hmm.
Okay, I got it.
Yeah. Sure. Yeah, speaking of that, then I think we could jump into, talking more about how Jupyter could be used in the developer's perspective. Sorry, question?
Yes, sorry. Just wondering, two questions, and maybe you'll talk about it later. So one question is the limitation here, is it the limitation of your widget, the limitation of the kernel, or the limitation of something else?
Yes.
And the second question is, what about interoperability between different, different language, different kernels?
Mm-hmm. Sure. I remember that. I will talk about those two things when I give the demo. I would certainly visit those two topics. Remember if I miss it. Okay. So the final feature I want to introduce from JupyterLab is that, so since JupyterLab has a very good ability to extend itself, and there are a bunch of developers, they are developing many useful extensions of that. And one thing here is about collaboration. So this thing, you can see this Google Drive icon on that, and that's connected to my drive. So actually I can open it up, and it's actually connected to my Google Drive. And if I share this with you, and you can visit this notebook, actually you will see a different caret there, a different arrow here, indicating who is editing this documentation. So this provides you with the ability to collaborate with others with Google Drive. So I think that's a very fascinating feature if you want to, a reason why you want to move your develop process to this Jupyter board. Yeah, so I think that's some features that I like about JupyterLab, and I will introduce several BeakerX features that I talked previously. So I will go with the doc we have inside here. Cancel this. So here is actually the documentation for BeakerX. As you can see, the documentation is also a notebook itself. And we will have, this is the kernels that we support for Groovy, Java, Scala, Clojure, another SQL kernel, and Kotlin. So actually, you can see this example for Java kernel. And those Java code could be executed, and you can see I'm writing a class there to give me the time.
What do the numbers mean on the left side?
Sorry, the numbers of.
There's numbers 3, 4, 4, 5.
The index of the cell.
Oh, this one.
Yeah.
Yeah. So this is index. Yeah, that's index of the cell. So this tells you the execution order. So if I run it again, you will see it's going to 6, and again it's 7, it's 8. So to tell you the execution of cells.
Oh, that's why it's changing.
Yes, and the execution counts. Right. So here also, in this kernel, you'll be able to draw plots. So that's BeakerX plots. Also, you'll be able to using this Jupyter magic, which started with a %. It's called % classpath, which is a magic provided by Jupyter, allows you to add a jar to the classpath, and then you can use that in this kernel. So that's the example of the Java kernel. I won't go too much detail into all the kernels that we provided. So I'll introduce some interesting features like this classpath and imports. Let's say here, okay. So actually we want to import a class, but actually that's not our class class, right? So we met with an error. But we could do that by this classpath adding magic, which load the jar from local and add it to our classpath so that we could use that class inside our notebook. Also, the wildcard also works. And we can not only load load those jars from, let's say, local, we can also load those dependencies on Greaves and Maven. For example, I'm loading a Maven, like this JSON package, and you can see this is added. And I think what's more helpful here is that when I write a passive magic, like class path add Maven, and let's say com, but I forgot, I can use tab to autocomplete. With this actually is fetching from the Maven repository, giving you the ability to autocomplete the jars that you want to import. So this is added by BeakerX. Sorry. And also you can have those Gradle-like syntax to load dependencies as well. Some dependency may not be jar, they could be POM, and they could also be added here. And you can load from your custom repository if you like. And certainly multiple dependencies with Maven. Yeah, so actually that we provide a ways for our JVM users to load paths from various resources. Also, when we're starting a JVM kernel, I think something different from a Python interpreter is that we may want to set some of our JVM main parameters, JVM options to pass in when we start a kernel. Things like heap size, or you want to add other properties. So in BeakerX, we provide with such a UI options where you can set those heap size and the other parameters you want to pass to your JVM kernel. So this is actually in the panel. We haven't moved that to BeakerX. We haven't moved that to JupyterLab yet, but it's available in this classic view. As you can tell, this is a UI config tab where you can tell the kernel the heap size you want him to use and the other properties you want to use. So you can see this would be the result we pass to when we start kernel. So we set a heap size and we set other properties. So we can get those properties inside the book, and that will take effect when I started a new JVM kernel. So I would like to talk about the polyglot experience. So as you can tell, so every Jupyter notebook has a kernel. So this is actually a Groovy notebook. So it has a Groovy kernel. Apparently everything, it means that by default, everything written here should be in Groovy. And for them like this, I could say BeakerX.full equals to a string, a Groovy value. And we will ask, what is this BeakerX? So BeakerX is kind of like a universal object we use it to store data across different languages. So actually you could name a variable, for example here I name it full, and store it inside BeakerX, this object, and in other language we could read from BeakerX for those variables we just passed in. For example, if I want to do that in JavaScript, you can see that I say alert BeakerX full, and it tells me a Groovy value. This is being passed to JavaScript, this front end. And also here, I'm saying BeakerX bar equals to a list from JavaScript. And we want to translate back to Groovy, and we get that value, so from JavaScript. Or we can do that to pass it with Python. You can see this is a % Python, which means this is a cell magic, means that all the code written in this cell are in Python. So in Python, we import the BeakerX object and then we get the variable passing from JavaScript. Also, there could be other examples like Scala, like Java, like Kotlin. So the syntax may be a little bit different because every language has their own syntax, but the underlying data is saved in this BeakerX, and it gives you the ability to pass data around different languages. And for example, here I'm passing in a pandas data frame, and this data frame, I've been mixing right click and left click all the time. Yeah. So I save this data frame, load it from the CSV, and save it in these rates. And now I'm reading those rates in the Groovy kernel, so I get those rates as a list. So we have the ability to pass a very complex object like a Python data frame and convert it into the readable data type in other languages. There are many challenges in this process, like the type inference. It takes a bunch of time to work. Actually, you have to write interpreter for almost all the data type for each language. But in general, we have a general auto-translation between all these JVM kernels, Python and JavaScript. So these are like toy demo. I want to introduce something more usable. So here I have an example to auto-translate Groovy into JavaScript. So here I'd like to do is I want to generate some graph and link, like a social network, and I want to do that in Groovy. And then I would like to pass it to a JavaScript library, D3, and use that to help me visualize this data. So here in Groovy, I read those code. It gives me nodes, and links. As you can tell here, I'm saving it in BeakerX graph, nodes and links. So the output cell is hidden, you may not see anything, but the data is transferred. And here I'm writing another JavaScript cell. So this JavaScript cell load the D3 library using require, so that I have D3 in my browser now. And then running this HTML cell, which defines the style I want to use for the visualization. This part is the code for visualization, and that's almost copy and paste without modification from the D3 website. The only thing we changed here is that we need to pass in our data, right? So we say graph equals to BeakerX graph, and from then on, all the graphs are using the data we're passing from Groovy. And when we execute that, so this will have the visualized social network. Since it's visualized with D3, it's good, it's interactable. Right? It's running the JavaScript on the client side, and the data we get from a Groovy kernel. So that's auto-translation. I think auto-translation may not be used that widely. So for example, you may have 90% of your work in your in the language that you have expertise in, but for the 10%, like reading a data, like doing a visualization, there may be other languages that are better or easier. So in this case, you'll be able to integrate them more easily without, let's say, to use this to write our own web server or to pass data between these two languages manually or write a different parser for the language. You don't have to do that. You can have this polyglot experience inside the book. I think that's why we bring polyglot into this scenario. Besides that, I want to have a very quick review of the interactive widget that we generate. So, for example, we can read CSVs, and we'll prove that we have the same ability like pandas in Python. So we could handle data and CSV file very easy with those interactive cells. Let's say you want to find some patterns here, so certainly you want to do some interaction like sorting. I can want to do sorting here, so you can sort by time, sorting by other values. You can have other visualizations, like if you want to say the heat map of those data. If you want to show some data bar of the data, telling me much or less. Or you can do things like change the order of the column. And if you mess things up, you can recite those interactions. And if you want to do things like, oh, I found something interesting here, you can do some selection. And this is not limited by row. You can do rectangle sections like this, and then copy those to your clipboard, and let's say move it to Excel, and paste it here. As you can see, this is the rectangle data I just selected, and the column name is automatically added for easier to use. So basically, that's the table widget we have. It also has other stuffs like showing different time. I'll just run them one by one. So this is fixing a column to the left and setting the precisions. This is having heat maps in the table. This is having different colors, heat maps per column, and unique color them by unique values. Change font size, and I think the interesting here is that you can program some actions to the table. So now I have a table here, and I'm using this API called set double click action there. So actually, when I run this cell, so it's adding another hook on the table cells, and when I do things like double click, it actually gives me a sum. As you can see, I'm double clicking, and numbers are just changing. Also, you can see there's an add context menu, negate. So I right click, there's a thing called negate, so you can turn it into an active value. This will help you build up some interactive UIs and inside Jupyter. Questions?
Yes. Quick question about interactive UIs.
Sure.
Do you have a possibility to set up a restricting policy somewhere so that on resulting UI, actions that can expand the data being displayed beyond what was originally intended are not available?
Can you say it again? Sorry.
You're showing dynamic UIs, all
Yes.
sorts of.
Yes.
But that means, for example, if a client gets that,
Mhm.
apart from purely visual changes, like putting a column somewhere or adding some basic analytics inside, he or she might be able to add integration into other data which was not supposed to be available to him but is available on the back.
Oh, I see.
So, do you have any kind of ability to restrict the actions of some kind, like policy type of stuff that you can put on top of whatever you publish?
Yes. For example, I could say, so this widget is actually portable, and we have this, we have made this widget available in Jupyter, and that's we pass those wrap it up and pass to npm. So you can see things like publish. Essentially, I can publish this specific table, and I will put that into a GitHub gist. That's where we store our shared data. This will ask me to give a personal access token. So I will give it there. And then this data could be published to my personal GitHub gist. And you're just seeing it open up with NB Viewer. So this could be shared with others. And others, if they want to apply those with their data, they could go to this NB Viewer and have it download. So for example, this is another notebook I shared today. So it's another example for us. As you can see, I'm doing visualization here with the interactive widget we have.
Mm-hmm.
And this is still being interactive inside this MB viewer, so it's outside of Jupyter environment. It still remains interactive. And also, there are options that you can open up viewing a gist, or you download it on your site, or you open it up with Binder. So Binder is a tool that could open up your Jupyter service according to a specific GitHub repo, so that this could be run automatically as a hosted service, inside the browser, to run this notebook directly. Yeah, sharing data could be easy, but sharing the environment is very difficult indeed. I think Binder is the solution we have for now. And inside to Sigma, we will have like a hosted service that could share a bunch of environments. Jupyter also have other extension that could help you share environment. In Python world, people use conda. So there's an extension in Jupyter called NB conda kernels, allows you to select a kernel according to different conda environments, and you could share those environments with others. So that's about publish. Yeah, and I just showed you the interactive widget and publishing. So this actually completes the vision I just talked about. The last thing I want to talk is the Spark integration. So here, if you want to do something like a distributed computing and managing Spark jobs, Spark sessions, let's say I'm doing it in Jupyter Notebook. So first of all, I'm going to import this module into my notebook. So I add it from Maven, add a Spark SQL here. So it's actually huge, a bunch of stuff here. And then I would start a kernel. I would start with %% Spark. This means a user interface will pop up here, asking you to specify the Spark configuration you want to pass to this Spark instance. As you can see, you can say the master URL, the executor course, the memory, and other variables can be fetched here. Certainly you can add the names and values and then pass it to a Spark session. Also, this could be pre-rendered. So if I say start here, sorry, this is small, and this is not showing correctly. This actually create a new profile, and yeah, this means create a new profile, which means that you can save all your configurations inside the JSON file so that you can use them later if you want to replicate work. As you can tell, I just hit start, and here's a icon indicating that Spark session has been already started on the back end. And I could then do some Spark job. Like here, I'm having a code sample, calculating the value of pi for me. This is too fast. Sorry, I will command it by 10. Okay, I will another 0 here. Oh, sorry, did I?
Can the data be continuously fed? Kind of reactive approach.
Sorry?
Can the data be continuously fed into the resulting frame? Kind of reactive approach.
Yes. So actually, you can fetch your data to your. Let's say you have another job, and let's say you have another job passing, and the UI here showing the jobs you're doing, and they will become stage 2, and then you'll be able to monitor them. And there's a link to the Spark instance, so that you can monitor them. For example, in here, I'm opening up the CSV files. So actually, it's just giving me the preview of the different column types. But if you want to preview more rows, certainly you can pass in the number, and the job will get